Alright, Nordberg Railway Equipment Division. Nordberg Railway Equipment Division. Nordberg Model B Hydra Spiker. Rex in Oxford. Nordberg Model B Hydra Spiker. Right in Oxford. This manual is a guide of operation routine maintenance for the Nordico Railroad Maintenance Machine. Covers the product technical information, basic operation maintenance procedures, and safety information. Is provided by the use of qualified personnel who supervise, operate, and service the equipment description herein. The measurement in this manual, given the metric customary unit, is unit of equivalence. Personal responsibility for operation maintenance of the equipment should be thoroughly studied for the manual before commencing operation maintenance procedures. This manual should be considered a permanent part of the machine and should remain with the machine at all times. An additional copy of the manual available as part of the operational maintenance operation manual only or whole operation parts manual nominal cost throughout the part of sales. Additional sales information, parts application information is available through these Nardico products support resources. Sales, service, and parts. Numbers. We ask that if you have any comments, suggestions about this book, let us hear from you. We are here to be service to you, our customers. Direct your comments and inquiries. Nordico Technical Documentation Department, Nordico Incorporated, 245 West Forest Hill Avenue, Oak Creek, Wisconsin 53154. Hazardous material data. In an effort for providing with the information necessary for the employee safety training and to meet the requirements of the OSHA Hazard Communication Standards of 1910.1200, we have OSHA Form 20 safety data sheets available for the cover of the material contained in this machine. If you are interested in receiving information, please refer to your name, model, serial number of your machine when calling or writing and directing your inquiries to Vice President of Operations Nordico Incorporated, 245 Hill Avenue, Oak Tree, Wisconsin 53145. Fax 414-766-28289 and 414-766-2249. Alright, your Model H Hydra Spiker specifications. Engine model, general metals, the DDAD 5330. 5033 7001. Entering operating speed is 2250 RPMs. Relief valve with a 56 gallon per minute pump system at 2500 psi and gallons. Relief 5-gallon pump system, 1000 psi G. Relief Niper system, 850 psi with gallons. Machine total length of 15 foot. Max machine wheelbase is 110 inches. Machine height with enclosure 8 foot 1. Without enclosure 7 foot 4. Machine width 8 foot. Machine weight 17,000 pounds. Machine travel speed 21.5 miles per hour. Hydraulic oil tank capacity 38 gallons. Engine fuel capacity 53 gallons. Description: engine controls and gauges, throttle control, electrical system key switch, electric start button, cold start valve, engine normal stop pushing button, engine stop handling, engine shut off valve, reset handling gauges, main operating controls, propulsion valve, foot lever, proportional brake lever, proportional brake switch, left-handed spotting valve, right-handed spotting valve, gun control triggers, Niper down, thumb button, hooks, close thumb button, speed feed, thumb button, auxiliary controls, set off the cylinder, flow valve with the control valve, winch motor control valve, optional hand pump, winch motor control valve, optional hand pump, adjustment, spiking pattern adjustment, jaw release timing, Niper frame up, propulsion chain, opto, encoder, switches, rail clamp, opto, switchers, guns ready, opto, switches, guns up to opto, switches, operation procedure, auxiliary hand pump, release of the rail hooks, raised right hand driving guns, raised left hand driving guns, release of the brakes, lower set off the cylinder, raise the set of the cylinder, release the nipper and hooks, release the nipper frame. Preparing the machine for propelling and towing, propulsion or towing all the machines, propulsion only, optional proportional braking, towing only all machines, preparing machine for operation after propelling or towing, propulsion or towing all machine, propulsion only, optional proportional brake, towing only all machines, spiking procedure, setting of the machine off the track, lubrication, hydraulic system, engine, propulsion assembly, propulsion pedal, pivot pin, propulsion valve, chain link, propulsion roller change, propulsion chain adjusting screw, axle pillow block, hydraulic system, description test procedure, large pump system pressure, small pump system pressure, propulsion system, rail hooks down pressure, nipper frame up and down pressure, nipper frame up and pressure. The Nordberg Model B H Hydra spiker is totally a new spiker in concept. Is designed. The new computer formulated tubular mainframe is ultimately the fabrication technology. Each critical juncture high stress area has been pinpointed through the lengthy computer studies and applied with the reinforced with complete emphasis. Simplicity, the Model B Hydra spiker is easy to operate, simpler to maintain. For spiking guns to each side of the machine, electronically controlled. For 4 spiking guns and 2 each of the side of the machinery, electronically controlled through the logical system of the program to ensure the precise, proper, sequential operation. 2 joystick control spotting for the 2 gun sets, and 1 at each side of the machine for the 4 proportional valve. The trigger box, which is integral with each of the joystick levers, responsible for initiating, stopping, spiking sequence individually. Spiking gun. Hydraulic spiking cylinders drive the spikes without the impact of the force of about 10,000 pounds. For the rail clamps to add each side of the machine, automatically hold the machine to the rail against the opposition of the spiking force. Whenever any one spike gun is set at the ready position, a hydraulic motor coupled with the rail axle through a chain drive propels the machine at a speed range through a lower slow crawl of 21.5 miles per hour. Spring set dual threaded type. The brakes are automatically set and released through a pilot signal with a propulsion valve to hold the machine with greater deceleration, propelling a large diameter, long stroke set off the cylinder is permanently mounted to the center of the balance to raise the machine for the turnaround around with the set off. Various optional equipment is available to provide easier and faster operation. Hydraulic operated with lift spike keys on the machine with the ease. The hydraulic nippers electronically controlled the thumb button at the gun trigger box. We will raise and lower the tie and hold the ties resting on a loose balance tightly against the rail base during spiking. Engine control gauges. Engine control and gauges. Throttle control. The throttle control lever is located just below the gauge panel. The figure 1 engine speed is increased, pulling the throttle and handle back toward the operating decrease by the pushing handle forward. For non-operational engine should be running at high idle speed at 22,250 RPMs with the throttle pulled all the way back. The electrical system key switch. The electrical system key switch is located on the right of the engine gauge panel next to the engine stop button, stop push button. The electrical system is energized by the turning of the key to the right. See figure 1 turning the key to the right while energizing the gauges at the gauge panel. The nipper manual control system, the logic system, and the starting system. The turning of the key switch to the left in an upright position will shut off the electrical power to the electrical system devices with the exemption of the engine stop circuit. With the exception of the engine stop circuit and horn circuit. The engine start push button. The push button to the left of the key switch at the engine of the gauge panel of the engine start push button. See figure 1, which the key switch is closed but the throttle lever cracked open. The engine may be started by the depressing of the engine start button. Once the engine has fired, the start button must be released. The cold start valve. The shut-off valve at the top of the mainframe, the superstructure in the front of the left-hand operated station is cold started valve. See figure 1, manually operated valve provided with diverted with the oil from a hydraulic pump directed to the tank. This reduces the burden of the engine to permit the faster engine turnover. The cold weather starts to dump the oil directly to the tank, turning off the valve handle counterclockwise or outward. One of the engines was warm up and close. Once the engine has warmed up, close the valve and turn the handle clockwise in the inward. Alright, engine normal stop push button. The push button with the extreme left and the right ends of the engine gauge panel are at the engine normal stop push button. Pressing either push button will energize the solenoid that will place the engine fuel racks in the no fuel position. Once the engine is stopped, release the push button and the fuel racks will return back to the governor control. Emergency stop handle. An air shutoff valve is installed with the air inlet housing to shut off the take of the event of the abnormal condition. The engine should continue to run after the normal stop push button is depressed, or the engine should overspeed during the combustible gas introduced through the intake air system. The emergency stop handle must be pulled all the way out to stop the engine. The emergency stop handle must be pushed back in and shut off the valve. Reset before another start is attempted. Refer to the instructions under the emergency shutoff valve reset handle. The emergency shutoff reset handle. Whenever the emergency stop handle has been pulled out of the stopping engine, the air shut off the valve and the airlet manifold must be reset. For another start to be carried out with the emergency stop handle must be pushed all the way inward. The emergency shutoff valve, the reset handle must be pulled all the way outward and then pushed all the way inward. This will reset the shutoff valve in the one position, allowing to take in the air of the intake manifold, permitting the engine to start. Gauges. The gauges of the electrical system, engine water temperature, the engine lubrication, oil pressure can be monitored. Watching the gauges mounted on the gauge panel. The voltmeter is at the left, the oil pressure is at the center, and the water temperature gauge is at the right. Alright, figure 1 shows the engine shut off button on the left and the far left and right, then followed by the horn button on your left, voltmeter, throttle control level, oil pressure, light switch, water temperature, 30 amp circuit breaker, engine start button right next to on the right side, next to the key switch, and the engine stop button. The cold start valve is also pointed out in the left top right hand corner. Main operation controls: propulsion valve, foot lever. The foot lever and the deck will all left and the right hand operating stations control the propulsion valve, which directs the propulsion motor for the propelling of the machine. See Figure 2, with the propulsion valve lever is depressed either the direction of the pilot signal is sent to make the brake valve, releasing the brake. At the same time, the opto switch transmits a signal with the logic system, which is logic system, which raises the rail hook. Depressing the left side of the propulsion foot lever raises the brakes and raises the rail hook, and the machine will be moved forward. Depressing the right side of the propulsion valve with the foot lever releases the brake, raises the rail hooks, and the machine will move backward, and release the foot pedal will stop the propulsion motor and set the brakes. Alright, Figure 2 shows the propulsion foot lever on the left-hand station pictured, and the propulsional brake valve optional on the Figure 3. Propulsional brake lever, optional equipment. The lever with the ball grip lever with the ball grip at the top of the mainframe structure controls the proportional brake level. See Figure 3. The proportional brake switch is on and oil directed through the proportional brake valve in the brake cylinders, fully releasing the brake. As this proportional brake lever moved downward, as the pressure of the brake cylinder will reduce the proportion of the amount of the lever that is moved. The brakes will be gradually applied until they are fully applied with the pushing lever in the maximum downward position. Releasing the lever will return the valve lever to its mid-position. Brakes will fully release, and the proportional brakes provide a means for slowing down the machine traveling higher speeds and control speeds with the coating down a steep grade. Proportional brake switch, optional equipment. The toggle switch at the left side of the gauge panel next to the horn button is a proportional brake switch. See Figure 1 prior to the option rating proportional brake. The proportional brake switch must be in the up and one position. And once the proportional brake is no longer to be used, the proportional brake switch is returned to the center or off position. When the switch is on, a solenoid valve energized with the proportional brake is braking, then the control with the proportional brake lever. The propulsion valve foot lever has no control over the brakes. When the switch is off, the solenoid valve directs oil through the pilot operating brake valve, and the brake control is returned to the propulsion foot lever. Alright, your left-hand spotting valve. The valve is mounted with the transverse beam in the front of the left-hand operating station. Left-hand spotting valve. The spotting valve of the lever pivots the ball and socket type. The mounting actuates for the individual valve spool. Each valve spool directs the hydraulic oil to the one of the two-spot cylinder, which moving the spiking gun carriage ahead, back to the left or to the right oblique, and the spotting of the cylinders are operated by placing each hand around the control handles with a trigger finger through the trigger guard. Then tilting the control handle assembly will move the spike gun carriage in the same direction toward the control of the tilted handle is tilted. Right-hand spotting valve. The valve mounted on the transverse beam in the front of the right-hand operating station. The right-hand spotting valve. The see figure 4. The spotting of the lever valve on the ball. The socket type of the mounting actuates the individual valve spool. Each of the valve spool directly hydraulic with only one two-spot cylinders, which move the spiking gun carriage. Ahead and back to the left and the right, and obliquely the spotting cylinders are operated with placing each of the hand around the control handles and with the trigger finger through the trigger guard. This the tilting of the control handle assembles the moving of the spiking gun carriage in the same direction toward the control of the handle is tilted. Alright, here is your nipper up and down thumb buttons with a nipper hook button. Your left-handed gun switch, gun spike feed button. Your right-handed gun spike feed button. Right-handed inner spiking gun trigger. Right-handed outer spiking gun trigger. Right-hand spotting valve. Gun control triggers. All 4 gun control triggers are operated identically. See figure 4 for each of the trigger has 3 options. There are 2 opto switches, gun up and gun down, which are either exposed or obstructed with the triggers. They're moved to alternate positions. When the triggers are in the normal free release, the down opto switch is obstructed and the up opto switch is exposed. Exposing the up opto switch is energizes the gun up to solenoid, and the gun will be in the full up position. Moving the trigger to the mid position obstructs both opto switches, but transmits the gun down to the output signal. The gun lowers the gun down. The signal initiates the hook down signal, lowering the rail hooks. The gun is descending up until the spike is between 1 or 2 inches above the tie plate, at which time the gun is ready to opto and switch to the de-energize with the gun solenoid. With the gun stops, the movement and remains in the set position. The trigger at the time can be replaced by when spotting of the guns as a logical system, while and will be unaffected with the input signal and other transmitted with the gun drive signal in the trigger position. Moving the trigger to full back position. 3 exposes the down opto switch to the truck. The up the opto switches. Exposing the gun down opto switches energizes the gun solenoid. The driving cylinder drives the spike. If the spike has been driven, the trigger is released. Returns the spring force for the free release position of the gun down opto switch will be obstructed. De-energized the gun down solenoid, and the gun up the opto switch will be exposed. Energizing the gun up solenoid, the gun will come up to the full up position. The gun up side with the driving cylinder will remain pressurized until the gun down solenoid is energized. The nipper down thumb button. The nippers down the thumb button is located with the back side of the left-hand trigger of the box at each of the gun control assembly. See figure 4 with the type of the tie nippers can be operated with either by the operational station. The nipper down thumb button that has 2 positions. The one opto switch, the nippers down, this is exposed and obstructed as the button is moved to its alternate position. The 3 release position, the nippers down up 2 switches are obstructed. The pressing of the button exposed for the opto input signal is sent to the logical systems. Pressing the nippers down button alone will energize the nippers down solenoid. The nippers will lower. The release of the nipper down button will stop the movement, but the nipper frame will remain at the set position. Depressing the nippers down, the thumb button will simultaneously depressing the hook's close button will energize the nippers up the solenoid valve. The nipper of the frame raises to the full position rail. Raise either both the nippers down and the hook closed. The thumb button will discontinue the nippers up output signal. Pressure the upside of the nipper frame cylinder will be continuous. All right, your hooks closed thumb button. The hook's closed thumb button is located at the backside of the right-hand trigger box at each of the gun control assembly. See figure 4. The hook closed with the thumb button has 2 positions. There is one opto switch to the hook closed. The exposed but the obstructed with the button is moved to the alternate positions and the free release position. The hook closed opto switch obstructed with depressing the thumb button. Exposed the hook closed opto switch and a hook closed input signal transmitted to the logic system. Depressing the hook closed thumb button alone energizes the hook closed solenoid. The hook will close, and releasing the hook closed thumb button will discontinue the hook's close. Output signals pressure of the closed side of the outside hook cylinder will be continuous. To open the hooks on the hook closed thumb button is released, and the depressed logical control system is designed to energize the closed solenoid, and the open solenoid is in alternate sequence. Each of the time the hook closed thumb button is released, the depressed and mentioned under the nipper down thumb button, the nipper frame is raised and simultaneously depressing both nipper down and the hook closed thumb button. We'll go back to figure 4. Your nipper up and down thumb button, hook button, left hand gun feed button, right hand feed button, right hand inner spiking gun trigger, right hand outer spiking gun trigger, right hand spotting valve. Alright, your speed thumb button. The spike feed thumb button is lowest between located at the back side of the trigger box at each of the gun control assembly. See figure 4. The left gun is controlled with the left hand button. The right gun controlled by the right hand button. Each of the gun control assembly. Each spike feed thumb button has the 2 positions. There is one opto switch to the spike that is exposed but constructed as the button is moved to alternate positions. It is in the free release position of the spike load up to the switch is obstructed with depressing the thumb button and exposed to the opto switch with the input signal, and is sent to the logical system. Pressing spike feed with the thumb button will energize the spike load solenoid, and the spike will be pushed for the ready position by the pusher block with the spike jaw driving, releasing the spike feed with the thumb between the retracting push blocks. Activity of the spike and escape cam will always allow the next spike to slide down to the tray of the ready position, the feeder frame in the front of the pusher block. Alright, your auxiliary controls. Set-off cylinder valve. The valve mounting at the end of the front of the train. The valve mounting on the right front of the tubular mainframe is the set-off cylinder valve. See figure 5. To lower the cylinder ram, raise the machine, move the lever to the upward position. To raise the cylinder and lower the machine, place the valve lever in the lower position against the valve lever stop. Whenever the set off the cylinder is not being used, the valve lever must remain against the lower valve of the lever. The maintains pressure up to the side of the cylinder, keeps the cylinder from ram from creeping downward. When not in use, the padlock is placed therefore through it, so to set off the cylinder valve, stop the bar and around the valve handle. Figure 5 shows the set-off cylinder valve with the flow control valve adjusting knob and the valve handle showing the cylinder ram up position. Set off the cylinder flow control valve. The set off of the cylinder control flow. The set off cylinder flow control valve is piped into the set off control valve. Set off cylinder valve return line into the tank. See figure 5. The valve controls flow for the oil returning to the tank. When the cylinder is being raised, the machine lowered. The descent of the machine could be slowed, easier alignment, and the lower onto the rails. To slow the flow, descent with the machine turned with the flow control valve, adjusting the knob inward and clockwise to increase the flow speed. The descent with the machine turned with the flow control valve, adjusting the knob outwards or counterclockwise. Winch motor control valve. Optional equipment. The valve mounted in the winch was mounted to a winch boom winch control valve. The see figure 6. Moving the control valve upward will reel the cable on the winch spill where it raised the load. Moving the valve cover the mid position will stop the winch, and the load will be held at the set position. Moving the valve downward and will lower the load. Figure 6 shows the winch control lever, lower raise, and the boom. Winch control valve. The optional equipment of the flow control is installed with the pressure side of the winch motor control valve. The flow oil with the motor can be adjusted for the speed up and slow down with spool rotation. To slow down the winch speeds, loosen the lock nut and turn the adjusting screw inward or clockwise. To increase the speed, loosen the lock nut, turn the adjusting screw outward or clockwise. When the dropper speed has been selected, tighten the adjusting screw lock nut. Your hand pump. An auxiliary hand pump is permanently attached to the left side of the machine. See figure 8. But the hand pump can be hand pump can be used to perform certain functions where the positive loose hydraulic engine power. See the hand pump. The operating procedure after shutting off the valve open and the pump procedure pressure. The moving the lever of the ball grip downward and pumping the long lever of the bicycle grip into the quick successive strokes. Pressure that can be relieved and moving the lever with the ball grip in the all-way backward position. Figure 7 shows the flow control of the lock nut and adjusting screw, while figure 8 shows the disconnection of the control valve and the shut-off valve of the figure 8. Adjustment 8. Spike pattern adjustment. The position of the inner and outer gun of each gun set is in relationship to each of the other. The chain with the line with the plate hole arrangement of the new spike patterns can be selected. The guns either have been placed spaced wider apart or closer together with the guns can be located ahead. The other diagonal spike patterns, inner and outer drive guns, are most simultaneously aligned with the selected set of holes on each side of the rail. To adjust the spiking pattern, proceed with a spotting valve with the control valve. Spot the guns so that they are approximately centered in both forward, backward, and laterally. Spot the machine so that the guns are approximately in alignment with the tie plate holes. Loosen the locking screw in each adjusting wheel. See Figure 9. Turn the adjustment wheels until the inner and outer guns are centered with the desired tie plate holes. The small diameter wheel at the inboard side controls the lateral speed spread between the guns. Turn the small wheel to the right clockwise will move the gun further apart. With the turning of the wheel to the left side counterclockwise will move the jaws together. The large diameter wheel at the outboard side controls are fore, aft, and spread with the guns. Turning the wheel to the right and clockwise move the guns farther apart, and turning the wheel to the left moves the guns closer together. When adjusting the has been completed with the tightening of the locking screw. The jaw release timing. The exact point at which the jaw release the spike controlled mechanically and different rail heights will effectively timing. The jaws shall release the spike when approximately 1 inch of the spike is driven into the tie. If the rail height is increased, the guide rod clamp should be positioned higher on the rod and tightened. Figure 9 shows the locking screw, your locking screws, and your lateral adjustment wheel with your fore and aft adjustment wheel. Figure 9. Tightened. If the rail height has been decreased, the guide rod clamp should be repositioned lower on the rod and tightened. Figure C, Figure 10. These are the guide clamps, and they should be. Figure 11 shows the lock nut adjusting screw and the relief valve, while this one shows over here the nipper frame cylinder and the pressure tap. The nipper frame pressure. The pressure setting of the valve at the top of the frame directly in front of the operation station is the nipper frame up the pressure regulating valve. The C Figure 11 with the nipper frame up with the pressure regulating valve sets the pressure at which the ties are held against the rail base. When handling the ties of the softer wood, it may be necessary to reduce the nipper frame up pressure to avoid damaging the ties. The upward force of the nipper frame cylinder is excessive so that it break and crack, weaken the tie. The pressure must be reduced. To adjust the nipper frame up the pressure, proceed as follows. Install the pressure gauge and the pressure tap at the space and time of the nipper frame cylinder. See Figure 11. See the nipper frame up pressure in the constant gauge will immediately indicate the nipper frame circuit and release pressure. Pressure should be approximately 850 psi or less. Pressure is the pressure required. It should be set for the maximum pressure that will be damage to the tie. Loosen the lock nut and turn the adjusting knob inward and clockwise to increase the pressure, outward and counterclockwise to decrease the pressure. Figure 11 shows the lock nut adjusting screw and the relief valve with the pressure tap in the nip frame cylinder. 4. When the pressure has been properly adjusted, the tightening of the lock nut propulsion chain, due to the shock of the loading of the reversal rotation of the propulsion of the chain is subject to the chain. It should be adjusted nearly taut with just slightly amount of slack. The propulsion motor that is mounted with the pivot bracket that is raised and lowered, and turning the adjusting screw raise the bracket to lengths of the distance between the sprockets. Chain is tightened, lowering the bracket reduces the distance between the sprockets, and chain is loosened. To adjust the propulsion chain, proceed as follows. 1. Back off the adjusting screw lock nut. Turn the adjusting screw to the left and clockwise in the chain span and counterclockwise to loosen the chain. 3. Tighten the adjusting screw lock nut. Figure 12 shows the adjusting nut, the lock nut, the pivot bracket, and the propulsion motor. Alright, your OP2 ender encoder switches. The OP2 switches are compromised principally with the transmitter and the receiver. The transmitter and infrared light, with which only on all times the control of the receiver has a light-sensitive photocell, which exposes the light with the transmitter sends the input of the signal with the logistics system. The rail-clamped opto switch a vane is connected with the propulsion valve linkage and to obstruct the opto switch when the propulsion pedal is depressed. The clear of the opto switch when the pedal is depressed. When the propulsion pedal is depressed either direction. The signal is sent to the logic system to de-energize the rail hooks down solenoid. The valve returns to the normal rail hooks up position. If the rail hook raises or clear the rail whenever the propulsion pedal is depressed to adjust the rail clamp, opto switch proceed as follows. Alright, when the control power on the engine not running of the check light with the pilot light logical control switch control box with the depressor releasing the propulsion pedal, the pilot light should not be lifted with the propulsion pedal released and lifted when the pedal is depressed. The pilot light is not off in the movement of the propulsion pedal and proceeds to step 2. With the pedal released and loosened, the opto switch motion of the cap screws position the switch so that the vane centered in the opto switch. See Figure 13 for the tightening of the mounting screws. Figure 13 shows the actuator, opto switch, actuator vane, and the opto mounting screws. 3. Alternately depress and release the propulsion pedal with the pilot with the function correctly. Make further adjustments as necessary. If the pilot's light is not on with the pressing of the left side of the pedal, move the switch to the right, and conversely, depressing the right side of the pedal does not energize the pilot light, move the switch to the left. Guns ready to opto switch. The guns ready to opto switch tells the logistics system that the spiking guns have been lowered to where the end of the spike is 1 or 2 inches above the tie plate. When the logical spike system receives the gun ready input signal, the driven cylinder is stopped at the set of the position, enables the guns to be accurately spotted. The vane type actuator attached to the driving cylinder guide. When the driver's cylinder rod extends the point with the spike approximately 1 to 2 inches above the tie plate, the actuator vane will be between the transmitter receiver obstruction, infrared light, special inversion circuit transmission transmit signals with the transmitter light is blocked to adjust the gun running opto switch at the spiking gun proceeds to follows. Figure 14 shows the gun opto switch with the adjusting screw, the adjusting wing nut, the vane, and the opto switch with the gun guide rod. Alright, 1. Spot the machine so that the spiking guns are approximately aligned with the tie plate. When the engine running with the control power on and depress the gun trigger to the midway position of the trigger box, the spiking gun to be checked or adjusted. Check the distance between the spike and the top of the tie plate. Distance should be between 1 to 2 inches to provide enough clearance between the verifying tie plates and yet close enough to provide accurate spotting. 4. If the distance is insufficient or excessive, turn off the electrical power key switch, back off the adjusting wing nut, turn off the adjusting screw clockwise to decrease the distance, counterclockwise to increase the distance. Tighten the adjusting screw with the wing nut. The distance of the switch is moved with equivalent with the increase or decrease the distance between the spike and the tie plate. 5. With the engine running and the control power on, initiate the gun ready system, depressing the gun trigger in the midway position. Recheck the distance between the spike and the tie plate. Readjust if necessary. When the engine running with the control power, initiate the gun ready signal, depressing the gun trigger in the midway position. Recheck the distance between the spike and the tie plate, readjusting if necessary. Guns opto switch. The guns opto switch tells the logistics system of the spiking guns that have been retracted to full up position. When the spiking gun has been fully retracted, the actual vane of the cylinder guide with the rods obstructed with the opto switch limits to send the signal with the feeder of the logic system, which allows the spike to be released into the feeding ready position. When the spike is feeding, the thumb button is depressed. The operating procedures. The auxiliary hand pump, a hose with a female disconnection, each of the stored within the toolbox for the attaching of the hand pump to various disconnect the hydraulic system to actuate certain cylinders without the engine producing oil pressure. The hand pump could be used to perform the following functions: raise the lower, set off the cylinder, release the brake, raise the driving cylinders, release the rail hooks, raise the nipper frame from the release of the tie hook. All emergency disconnectors are installed between the control valve of the cylinder, is so that it is not necessary to operate of any of the controls to actuate the cylinder. One of the many of the cylinders have the hose connection of the opposite end of the cylinder will have the disconnect to provide means of venting the trapped oil into the cylinder, when in most of the cases blocked into the pilot operated check valves. Release rail hooks. Both the railway hooks and cylinders actuate the common disconnect with the release of the rail hooks with the emergency hand pump proceeds as follows. 1. Connect those hoses to the male disconnect. Connect the hose to the male disconnect the hand pump male disconnect. The figure is shown in 15. The rail hooks release disconnect this pipe with the valve mounted with the horizontal plate with the right side of the machine in front of the carriage of the gun tubular frame. Figure 15 shows the rail hose disconnected, rail hooks release disconnected. Disconnect the hose and pressure down with both of the rail hook cylinders. Open the shutoff valve of the pump with the hand pump until the rail hooks clearly of the rail ball. Disconnect the hose and then return to the toolbox to reconnect the hose to the rail hook cylinders. Then that would be removed from the vent the trapped oil. Raise the right hand driving guns. Each of the 4 spiking actuated separated to disconnect the raise of the guns if necessary to hook up to the hose to each of the gun disconnected individually. To raise either of the 2 right hand guns, the proceed as follows. Connect the pump to the appropriate disconnecting shown in figure 16. The right hand gun disconnects the pipe, then over the center of the valve is dismounted with the transverse beam above the right hand operation station. 2. Disconnect the hose at the downside of the individual drive cylinder that it is to be raised. And 3. Open the shutoff valve and pump the hand pump until the gun is raised into the upward position. Figure 16 shows the right hand inner spiking gun disconnect and the right hand outer spike gun disconnected. 4. Disconnect the hose, return the toolbox, cut off the shutoff valve, reconnect the hose that drives the cylinder that would remove the vent with the trapped oil. Raise left-hand driving guns. Each of the 4 spiking actuated separated, but the disconnect to raise the guns is necessary to hook the hose to each of the disconnecting individual to raise either the left-hand guns to proceed as follows. 1. Connects the pump to the appropriate disconnected shown in figure 17. The left-hand gun disconnects the pipe to over the center of the valve mounted with the transverse beam over the left and operating station. Figure 17 shows the left hand spiking disconnected with the left hand spiking left hand inner spiking gun disconnected. 2. Disconnect the hose to the downside of each of the individual driving cylinders that is raised. 1. Shut off the valve of the pump with the handle. Hand pump with the until the gun is raised to the upward position. Disconnect the hose, return it to the toolbox, close the shut-off valve, reconnect the hose to the driving cylinder, then that remove the vent and the trapped oil. Release the brakes. The brakes can be released hydraulically, mechanically, or a combination. The machine is to be moved a short distance. The brakes are going to be released hydraulically. If the machine is to be towed a long distance, the mechanical brake release must be installed to prevent the possible creeping of the cylinder rod. In preparation for towing later in this section, the detailed instruction installation of the brake release button. The hydraulic hand pump can be used to relieve the spring pressure for the adjusting of the nut and installing the brake release button. The brake cylinder at each of the machine must be actuated to release the brakes at all 4 wheels. Each brake cylinder is released in the same manner as follows. Connect the hose to the pump with the disconnect to the shown in figure 18. The disconnect is pumped directly to the brake cylinder body. Disconnect the hose to the side of the brake cylinder. Figure 18 shows the brake release disconnected with the mechanical release bolt. Figure 18. 3. Open the shutoff valve, pump the hand pump until the compressed coil is on coil with the brake release button now and being installed. Warning: when installing the mechanical brake release bolt, when the spring compressed with the hydraulic, be certain that not to place the fingers or hands between the adjustment nut or any other brake component where the spring could inadvertently extend and cause bodily harm. 4. Disconnect the hose and return it into the toolbox. Close the shutoff valve. 5. Reconnect the hose as the brake cylinder was removed from the vent and trapped oil. Lower set-off the cylinder to lower the set-off cylinder. Raise the machine with the receipt as follows. Connect the hose to the hand pump to the disconnect at the top of the set-off the cylinder. See figure 19. Open the shutoff valve. Pump the hand pump into the machine. Raise to the distance. The machine can be lowered and moving the hand pump control lever to the backward position. Disconnect the hose and return it to the tool and close the shutoff valve. Backward. Raise the set-off cylinder to raise the set-off cylinder to clear the ties and ballast. Proceed as follows. Connect the hose to the hand pump and to the disconnect the bottom of the set-off cylinder. See figure 19. 1 shutoff valve of the pump of the hand with the pump on the cylinder piston retracts the full position. Pilot operated check valve to prevent the cylinder piston from creeping downward. Disconnect the hose and return it to the tool and close the shutoff valve. Alright, figure 19 shows the disconnecting the lower cylinder with the set-off cylinder and disconnecting the raised cylinder. Raise the nipper hooks. Both nipper hook cylinders actuated with a common disconnect to raise the nipper hooks from around the tie proceeding as follows. Connect the hose with the hand pump to the disconnect the pipe to the valve at the center of the main frame in the front of the operator station. See figure 20. Disconnect the hose to the downside of each of the nipper hook cylinder. Open the shutoff valve and pump the hand button to the nipper hook as free of the tie. Figure 20 shows the nipper hook release disconnect. And figure 21 shows the raise the nipper frame disconnect. Disconnect the hose and return it to the toolbox. Close the shutoff valve. Reconnect the hose with the nipper hook cylinder and with the disconnected vent with the trapped oil. Raise Raise the nipper frame. To raise the nipper frame, the proceed as valves connect the hose of the hand pump to the lower disconnected pipe of the nipper frame cylinder in see figure 21. Disconnect the hose to the downside of the nipper frame cylinder. Open the shut-off valve, pump the hand button until the cylinder position retracts. Extremely position the machine is to be towed and left out with the hydraulic system. Pressure for the extended period of the nipper frame. Safety locks must be installed. See the instruction of the preparation for the towing. Disconnect the hose and return to the toolbox. Close and shut off valve. 5. Reconnect the hose of the nipper frame cylinder that was disconnected the vent of the trapped oil set. Preparing the machine for propelling and towing the machine, but the machine of the propelling and the towing of the long distance proceeded as follows: propulsion, air, or towing. Raise the rail hooks inserted with the rail hook lock pins. See figure 22. The rail hooks will be raised them into full position automatically when the machine is propelled. When the control power is first applied, the rail hooks are not in the up position. The machine can either be propelled a short distance and the key switch is monetarily turned off and turned back on. The pins are inserted through the pivot bracket with the main frame. When the spring loaded, the balls check with the must extend through the frame to hold the pins in place. The nipper frame must be locked in the up position. Raising the nipper frame, install the nipper frame lock pin. See figure 23. Inserting the lock pin, nipper frame, turning the pin to the lock bar within the channel bracket. Alright, this is your spring-loaded ball check in the rail hook lock pin. Your rail hook lock pin goes on the pivot block with the rail hook Propulsion only. Optional propulsion in addition with the items of the propulsion or towing. The propulsion brake switch must be placed on the position of the machine that is propelled with if equipped with the optional propulsional brake. See propulsional brake lever. Propulsional brake switch. Main operating control section with the propulsion brake switch and is on. The propulsional brake lever can be used to gradually apply the brakes and slowly propulsion speed when desired. Figure 23 shows the nipper frame lock pin with the channel bracket. Towing only. In addition to the items under the propulsion and towing, the following steps must be taken when the machine is to be towed. Leave the propulsion pedal with the release position. Do not depress the pedal with all towing. Even though the engine is running for the key switch off, the center release position of the oil pressure then will be generated with the rotating hydraulic motor is circulated with the directly tank with a build up of the pressure. 2. When the machine is being towed, leave the key switch in the off position. Install the brake release bolts at each bolt brake cylinder as follows. A. Insert the two-threaded brake release bolts through the holes of the cylinder plate with the bolts extend through the plate several inches. See figure 24. Install the lock nut on one edge and one onto each end of the thread brake release bolts that extend to the center plate. Turn the lock nuts up to the adjusting bolts with minimum 1 inch and threads exposed with each of the bolt. Thread the ends of the adjusting bolt into the thread holes of the rod and spring plate. Tighten the lock nut. Figure 24 shows the rod and spring plate with a brake release bolt with a lock nut and adjusting nuts and cylinder and spring plate. E. Place the adjusting nut on the free end of each adjusting bolt and turn clockwise until the spring is compressed and the coil and the brakes are released. Preparing the machine for operating after propulsion, propelling, or towing. The propulsion or towing all the machines that the machine has been propelled or towed. The worksite removal of the rail locking pins with the 4 rail hooks of the figure 24. Pull the pins out from the pivot of the brake side. The nipper frame with the lock pins must be removed from the nipper frame. Remove the lock pin from the rotating of the pin. Some of the lock bars in the free with the channel bracket folding the pin outward. See figure 23. Propulsion only. Optional proportional brake with the machine had been pulled to work and equipped with the optional proportional brake system. Proportional brake switch is placed on the off position. See the proportional brake switch within the main operating control section. Towing only. All machines. If the machine has been towed to all the work site, and remove the brake release button bolts as follows. Remove the adjusting nuts on each bolt and loosen the lock nuts. Turn the brake release bolt out of the rod end of the spring plate. Remove the lock nuts of the brake release bolt. Remove the brake release bolts and put all the parts in the toolbox. Alright, moving on to your spiking procedure. After all the preparations have been made under the preparing the machine for the operation after propelling and towing, all the necessary adjustments have been made and described under adjustment. Spiking operations may begin as follows. Energize the electrical system. Start the engine. Set the throttle to high idle normal running position. When the electrical system is energized, all 4 spiking guns will raise to the foul up the position response to the monitoring input signal to the logic system. The rail hook and valve will be in normal operating open position, raising the rail hook. 2. Propel the tie location aligned with the ties and the nipper hook. The tie nippers are used to raise the tie either below the rail base and not resting with a well-tampered firm ballast. When a tie is low and not on a solid base, it must be held securely with the rail base so that the spikes will be fully driven into the tie. The nipper sequence is correlated with the spike driving sequence following step 2, the spiking procedure. Immediately proceed with these instructions to nip the tie. Proceed as follows. With the electrical power of the nipper, the solenoid valve will shift the raise the nippers and depress the energized state of the hooks. The solenoid valve will open the nipper hooks, propel the machine so that the hooks will be in position with the fully straddled in the tie. C. Depress the nipper frame thumb button at left-handed trigger box and hold the position of the nipper frame and the properly positioned around the tie. Release the thumb button. The nipper frame cylinder will stop the position and will which is progressed at the time the button is released. D. Depress the hooks of the thumb button, the right-hand trigger box, and then hold the position when the hooks are fully clamped around the tie. Momentarily depress the nipper frame thumb nut button. This must be done while the hook's thumb button is also depressed. The combination of these two signals will lock the nipper frame and the hooks closed. Signal and pressure that these cylinders will continuously maintain even the buttons after the release. Alright, E. After the spikes have been driven in step 3 and through 6, under spiking procedure, to press the hooks on the bottom of the release flip-flop. It will de-energize the hooks closed. Out signal with the hooks in the valve with the return of the normal the hooks, opening the position, opening the tie hooks. Since the pressure is still maintained with the upper side of the nipper frame, the cylinder, the narrow nipper frame will return to the upper position. 3. The pull the trigger at all 4 trigger boxes. Box will detent the position, the approximately midway position located with the feel or a slight resistance. Hold the triggers in the detent position until the gun stops automatically, approximately with the spike at a few inches above the tie plate. The gun drive out the signal at the guns actuating the rail hook cylinder, and the rail hooks will now engage the rail. The gun triggers can now be released as the gun ready input signal will be held with the guns in a set position with a logical receive the drive signal. 4. The spout of the guns is spiking protruding out of the spike jaws in alignment with the proper holes in the tie plate. Drive the spikes at all 4 guns. Pull the finger trigger all the way backward and hold until the spike at each gun has been driven and flush with the tie plate. Note, due to the variance of the tie plate, the location and position of the tie plate itself must be the driven guns in either rail may not always line up with both tie plate holes. For the reason it may be necessary to operate each gun separately for either aligning the second gun either but the first spike is driven. In this case, the signal shoulder should drive the inside spikes first. The machine rail lifts rail lifts when the spike is driven simultaneously. Drive one spike slightly ahead of the second spike. Alright, 6. When the spikes are driven flush with the tie plate, release the trigger at each gun. Release the triggers will shut off the gun drive and input the signal, and the spiking guns will automatically return to their up position. Once the spiking gun has fully retracted, the spike feeder thumb button can be depressed and released to load one spike into the jaws and another into the ready position. 7. Propel the next tie location. Depress the propulsion pedal. Release the brakes. Release the rail hooks. Propel the machine. 8. The machine has retrieved the new tie location. Repeat the procedure. Alright, setting the machine off the track. To set the hydro spiker off the track, proceed as follows. Select a solid area upon built with a set off crib. Erect the set off stand, and if so equipped. If possible, locate the crib and set off stand so that the center aligns between the two good level ties and turnable and can be straddled. Place the set off rail square on the crib and set off or the set off stand. Spot the hydro spiker on the track with the turnable lines with the center of the set off of the rails straddle two ties. The ties are unequal to height. Maybe necessary to shim one tie so that the turntable will bear on the level surface. The two ties can be straddled level on the tap suitable area between the ties. 5. The operator raises the machine on the turntable, moving the set-off cylinder selector with a lever the upward position. This will lower the cylinder, raise the machine, and when the machine is raised, the full height is manually turned 90 degrees. Alright, 6. When placing the runoffs in the proper position under the wheels, connect the runoff rails to the set-off rails. 7. Place the tie bar in position with the set-off and the runoff rails. 8. Move the set-off cylinder set off cylinder's valve lever down position with the withdrawal of the cylinder lower machine out of the runoff rails. The speed descent can be adjusted with turning the adjusting screw with the turntable flow control valve under the auxiliary operating controls. 9. Run the machine off the crib under its own power, blocking these wheels. 10. Remove the runoff rails into the clear track. Place the padlock through the set of the cylinder valve with the stop bar and around the valve handle. The padlock ensures that the valve will be in cylinder pressure up position when not in use. Lubrication, hydraulic system. The hydraulic system uses an SA10W40 detergent. The hydraulic system uses an SA10 weight non-detergent regular engine oil. The oil tank should be filled with 38 gallons of oil. When the oil tank is filled properly, the oil level will be in the full mark on the oil tank of the dipstick. It is important that the hydraulic system be kept clean and free of the dirt and moisture. There are 4 types of oil filters. Hydraulic system that should be changed when the conditions warrant. The 4 filters consist of a large pump, a small pump suction filter, large pump line pressure filter, and a small pump line pressure filter. The propulsion return line filter, see figure 25. A periodic inspection must be made to determine whether the filters are starving the pumps their proper oil supply, which would be slowed down with the function of the machine. Inspect the filters after the first 40 hours of operation and monthly thereafter. These inspections will determine any change of the frequency inspection which are necessary. Engine. Follow the instruction given to the engine manufacturer manual as to the type of the grade of oil, the frequency of the change are level with both of the cranking case and the air cleaner. Left angle gear drive, the grease, the 2 fittings of one each of the drive. Grease lubricated and see note number 1, lubricated with the pressure grease gun every 3 months of the 500 hours of operation. Add grease until the old grease is forced out around the shaft opening, see figure 25. Alright, here's your tank, your large small pump section filter, left angle gear drive, greasing fitting, large pump inline pressure filter, figure 25, and your propulsion return line filter, and your small pipe inline pressure filter. Propulsion assembly, propulsion pedal pivot pin, oil lubricated, see note 2, weekly, every 40 hours operation, apply oil around each end of the propulsion pedal pivot pin, or both at both propulsion pedals, see figure 26. Propulsion valve chain link, oil lubricated, see note 2, weekly or every 40 hours operation, apply only to the pin and is underside of linkage to each side of the propulsion valve, see figure 27. The propulsion valve and the oil pins. Propulsion chain adjusting screw, grease lubricated, see note 1, monthly every 200 hours operation, apply a coat of grease to the propulsion chain adjusting screw threads. Here's figure 28 with the propulsion motor and the grease oil on the chain. Axe pillow block, 4 fittings each of the pillow blocks, grease lubricated in the figure 29. Every 3 months, every 4,000 hour operation, lubricated the axle pillow block, anti-friction bearings. These pillow blocks will contain the correct amount of grease when the lubricating begins to come out of the seal. The fittings are protected with a plastic cap and turned off prior to the servicing, see figure 29. Figure 29 shows the axle pillow block greasing fittings. With figure 30 shows the grease nipper grease and the nipper hooks. Alright, note 1, grease fittings. The grease fittings should be reserved to multiple types of the grease suitable with anti-friction sleeve bearing application. Check with your local supplier recommendation for the proper lubrication. The grease fittings should be wiped out, cleaned before servicing. Sleeve bearing fittings increase the sufficient quantity of lubrication forced of the old grease until the new grease is visible. When servicing an anti-friction bearing encasement, the housing, the bearing cavity will contain the correct amount of the grease. Lubrication begins at the come out of the seals. Note 2, oil lubricated components. Engines oil should be applied to the oil lubricated components of the friction surface of the moving parts. Hydraulic system, the description. The hydraulic system utilizes the 2 engine-driven pumps to supply oil under pressure to the various hydraulic cylinders, motors, and pumps that are connected with the individual device. The hydraulic system pair oil type of the hookup that is in the pressure inlet. Each of the individual valve is connected directly to the pump outlet side of the valve is connected directly to the tank. Since the inlet and one of the valve is connected with the outlet valve with the proceeding with the valve in the circuit, the valve can be operated simultaneously. Flow of the large pump is divided with a separate flow that's simultaneously directed with the rail. The clamp the cylinders, set off the cylinder, let off the right hand clamp the driving cylinder, propulsion motor of the nipper frame, the nipper hand, the cylinder, the small directed oil of the brake cylinder, left hand, right hand spotting cylinder, the brake spring set with the hydraulically release. The brakes are hydraulically released in response to the pilot signal of the propulsion system. Propulsional brake optional equipment will apply with the brake progressively with the gradually slowing of the propulsion speed. Operating the driving cylinder with the nipper cylinders and the rail hook cylinders are controlled through the logical system in response to the input signals received in the various opto switches. Remaining the cylinders are controlled with the manually operated hydraulic cylinder valve. The hydraulic valves. Pressure of the various devices in the system are held at levels controlled with the relief valve. The important that the pressure accurately maintaining the level recommended for the safe and proper operation of the machine. Detailed testing and adjusting procedure for the giving under the testing procedure. Read and follow these instructions carefully. Testing procedures. Generally, in order, the test procedure can accurately conduct the following steps must be taken. Check to be sure the manually operated shut-off valve from the tank is fully open. That there's one shut-off valve for the large, small pump, for the large and small pump system. Start the engine and run at the idle speed of 900 RPMs for 15 minutes. If the cold start valve is open prior to the starting the engine, make certain that it's closed tightly. Position the throttle and operating at speed of 2250 RPMs. Large pump system pressure. To test the adjusting large pump system pressure, proceed as follows. Instill the pressure on the pressure tap of the large pump relief valve shown in Figure 31. Loosen the lock nut of the pump compensator. Turn the adjusting screw with the way inward clockwise. Large pump system relief valve. Loosen the lock nut and adjusting the screw in the inward clockwise to raise the pressure. Outward outer clockwise to lower the pressure until the gauge pressure reaches 2,500 psi. Tighten the lock nut at the pump of the compensator. Turn to adjusting screw outward counterclockwise until the pressure reading of the gauge is 2,000 psi. Tighten the lock nut. Alright, adjusting the lock nut screws the pressure tap and large pump relief valve. In 31, you see the small pump pressure tap, small pump relief valve, lock nut, compensating adjusting screw, large pump adjusting screw, and lock nut. Your small pump system pressure. To check out the system, small pump system proceeds as follows. Install the pressure gauge with the pressure of the tap at the small pump relief valve. See Figure 31. Loosen the lock nut and small pump relief valve adjusting screw. If the pressure valve of the gauge is not 1,000 psi, adjust the screw inward clockwise to raise the pressure, outward and clockwise to reduce the pressure. Once the valve is adjusted, the relief pressure of the 1,000, tighten the adjusting lock nut screw. The propulsion system. To adjust the propulsion system, proceed as follows. Install the pressure gauge with the pressure tap of the large pump of the relief of the shown in Figure 32 to the main pump and compensator adjusting screw until the pressure reading of the gauge of 2,300 psi. Press the check block under the wheels in front and the back. To press on one side of the propulsion pedal, either forward or remove the forward or reverse. Note the pressure at the gauge. The pressure should read the 2,300 psi. If the pressure or less is greater than 2,300 psi, both the acorn nuts and loosening lock nuts at both sides of the propulsion valve. See the Figure 32. Turning the adjusting screw alters the pressure reading of the gauge inward to raise the pressure, outward to lower the pressure. See the reading of the pressure gauge at 2,300 psi. Remember the pressure. Remember the propulsion pedal remains dead pressed throughout the adjustment procedure. When the proper pressure is reached, tighten the lock nut. Replace the acorn nut. 6. Repeat the pressure opposite, adjusting the screw with the propulsion pedal to press in the opposite direction. 7. Turn the main pump compensator, adjusting the screw out until the pressure reading of the gauge is 2,000 psi. Rail hooks downward pressure. The rail hooks do not clamp the rail, but instead of hook the rail under the rail ball. Since the hook engages the rail without meeting any resistance, high rail hooks down pressure is necessary. To test adjusting rail hooks down pressure proceeds as follows. Figure 32 shows the acorn nut with the lock nut and adjusting screw in the propulsion valve. Alright, HP Hydrospiker 8. Hydrospiker B troubleshooting. Engine does not crank. Possible cause. Key switches off, circuit breakers trip, battery dead, or starter defective. Remedy. Turn the switch on first for key switch off. The circuit breakers tripped. First determine each of the causes of the electrical overload correct, then reset the circuit breaker. Battery dead. Check the acid level in each of the cell. Add water and required the charged battery. Check acid level and starter defective. Repair or replace. Engine cranks but does not run. 2-1. Engine emergency stop handle pulled out. 2-1. Reset the emergency stop valve on the engine air tank intake. Engine not getting fuel. All right. Check the fuel level fuel tank of the fuel necessary. Check the fuel line and shutoff valve on the bottom of the fuel tank to maintain or make certain it's open. Check the plug for the broken fuel hose, clean or replace the hose. Check the fuel filters for water drain if necessary. Check for the fuel filter for elements to dirt, replacing the clog. Engine defective. Refer the engine manual for the troubleshooting engine. All right, 3 pump. The pump does not develop. No hydraulic oil tank. The pump is run without oil in the tank. Pump damage may result. 311. Add sufficient oil to the tank to bring oil level above the add mark on the dipstick. 32. Suction line valve closed. Note that the running of the pump with the valve closed may result in the pump damage. Open the valve completely. Engine cold. Start valve opening. Main pump only. Close the valve. Remedy. Main relief valve troubleshooting. Main relief valve pressure. Noting oil blow passing any relief valve will cause oil overheat. Remedy increased pressure setting of the relief valve. Main pump with the compensator must be set lower than may relief. 3.5. Main pump compensator set too low. Remedy increase the compensator setting. Defective pump. Refer to the pump manual for the troubleshooting of the pump. 4. The machine will not propel. 4.1. The main pump is developing pressure. See Section 3. 4.2. Brakes not releasing. See Section 5. Propulsion release setting too low. Increase the release setting. 4.5. Defective motor. Replace the motor. Problem. Brakes will not release. Small pump will not developing pressure. Increase the pump relief valve setting. Check the pump for wear and damage. Brake valve not shifting. Remedy. Check the valve spool for the free motion solenoid is to be energized. 5.3. Propulsion opto switch is obstructed. Inspect the switch and clean the necessary. 5.4. Defective opto switch. Remedy. Replace switch. Brake cylinder bypassing oil. Remedy. Inspect and replace cylinder. Brakes 6. Brakes will not apply. Brake valve not shifting. Broken brake swing. Braking. Brakes will not apply. Brake valve not shifting. Remedy. Check the valve spool for free motion of the solenoid is being de-energized. Broken brake spring. Inspect the spring and replace it if necessary. Propulsion opto switch uncovered. Inspect the switch vane. Clean and readjust them if necessary. Brake shoes are worn. Inspect the shoes and replace if necessary. Defective opto switch. Replace the switch. Alright, 7. Guns, nippers, and rail hooks do not operate. 7.1. Power off switch. Turn the power switch on. Circuit breaker tripped. Determine the cause of electrical overload and correct. Engine cold start valve open. Close valve. Logic board fuse blown. Determine the cause of electrical overload and correct. 7.5. Optional proportional brake switch on. Turn switch off. Gun does not stop at ready position. Driving valve not centering. Check the valve spool for free motion of the solenoid being de-energized. Guide rod and clamps set low. Raise clamps. 8.3. Broken trigger detent spring. Inspect the replace if necessary. 8.4. Guns ready to op switch and not covered. Inspect the actuator adjusting if necessary. 8.5. Defective opto switch. Replace switch. 8.6. Faulty logic board. Contact Oxford Railway Equipment Division, Milwaukee, Wisconsin. Gun problem. Gun will not retract when the trigger is released. 9.1. Guns ready to op switch going past the switch. Reset the guide rod clamps. 9.2. Driving valve not shifting. See Section 8. Faulty logic board. Contact the Oxford Railway Equipment Division, Milwaukee, Wisconsin. Alright, 10. Spike will not feed when button is depressed. Guns with the op switch uncovered. Inspect the op switch actually. Clean and adjust if necessary. Spikes feed through jaws. Spike fed through jaws. Spike feed flow control valve open too far. Adjust the valve to open to the obtained desired speed. Spike. 12. Spike turning into the jaws. Bent jaws. Inspect the jaws. Replace if necessary. Feeder frame bent. Inspect the frame. Repair if necessary. Spike is not feeding completely into the jaws. 1. The bent jaw. Inspect the jaws. Replace if necessary. Jaw bend. Pushing worn. Inspect the bushing. Replace if necessary. Dirty or sticking feeding mechanism. Inspect and cleaning all moving in parts of the diesel fuel. With diesel fuel. Nippers do not penetrate ballast. Nippers down. Pressure set too low. Turn the valve adjusting screw clockwise to increase the pressure. Ties being broken during the nipping up of the pressure too high. Turn the valve adjusting screw counterclockwise to decrease the pressure. 16. Rails do not clamp extend. 16.1 propulsion opto switch uncovered. Inspect the switch actuator clean adjusting if necessary. Clamp valve not shifting. Check the valve spool for the free motion and solenoid is beginning and energized. 17. Reclamp and does not retract. 17.1. Clamp pilot. Check valve not lifting. Clean the valve with solvent below and dry and replace valve. 7.2. Propulsion opto switch obstructed. Inspect switch and actuator clean adjusting if necessary. 17.3. Clamp valve not shifting. Check valve spool for free motion and the solenoid is being energized. 18. Rail clamps and pushing rail in. Clamp pressure reducing valve set too high. Turn the valve adjusting screw counterclockwise to decrease pressure. And once again, that is your Hydro Spiker Model B Nordberg Nauticor Rec Oxford equipment. And that's the manual.